Okay, shall we start back? Any questions so far? If you guys also have any questions about previous lectures, that's also fine. And I'm also happy to discuss about anything else. Like if you read some news and you want to discuss about it, is also fine. Like some of you yesterday asked about ChatGPT, DeepSeek, what's going to happen next. I can give you my opinion. Of course, I don't have the crystal ball to predict the future, and these days it's very difficult to do so. But still, I'm also happy to have this kind of discussions. Maybe not now, maybe at the end of the lecture. Today's lecture is a bit shorter than other lectures because it's just a glimpse on some of the history of AI and what in brackets the future of AI. In fact, I call it the future of AI just because it's goes after the name of our recent paper, The Seven Pillars for the Future of AI, which is not really a futuristic vision of what AI is going to be, but most like some sort of manifesto, research manifesto, and call for collaboration for any of you who is interested in collaborating with us on one of these topics. So if there's no questions for the first part, we can proceed. So we discussed about how language is just a standard and how there's so much more involved than just a sequence of words and letters. And we also discuss about these nice analogies in computer science that sometimes are a bit misleading. In fact, also when we say that we are emulating human intelligence into machines, we may still actually be light years away from doing that, because even if you take the deepest of the deep neural networks, it's still very far from replicating the neuroplasticity of the brain. We have so many synapses and neurons in the brain that are in the same ballpark of the number of galaxies in the observable universe. So it's we're still far from even just emulating the structure of the brain. We said yesterday that it's a bit like we know the hardware of the brain, but not the software, but still hardware-wise, we may still be very far away. And it's not just a matter of how many neurons we have, it's also how efficient the brain is. If you think about it, the brain is relatively small, and it also doesn't consume a lot of energy, unlike maybe some GPUs, and it can do all these in a very efficient manner and very fast and very efficiently. And we are very far from emulating something like that. Now, as discussed yesterday with DeepSeek, we are also looking at this kind of questions. So it's finally, it's no longer just about how accurate an AI model is, but also how efficient, how much energy does it consume, how much space does it require, how many GPUs, how much computing power, and so on. So these are also important questions to be asked in the future, or even now, for those of you who are working on, for example, edge computing or IoT. These are all important questions to ask even now. But so yesterday we briefly talked about this. So the next age of AI supposedly is AGI, artificial general intelligence, where you have an AI that is not just an expert system, but reaches some sort of singularity and can do many things that we do and maybe even better than us. But as we discussed yesterday, this all boils down to how we define intelligence. So if we accept the fact that AI is going to be a disembodied entity that doesn't have any biological traits and hence cannot understand some biological concepts like pain and pleasure, then yes, I can see that we are going to reach that kind of AGI. But if we talk about an AI that is more intelligent than us in any sort of way, then I don't agree too much on that. Why? Because as we discussed yesterday, we are two different types of intelligences, biological and artificial. But it really depends on how you look at the problem, because some people, like the late Marvin Minsky in this interview, said that we ourselves are machines. And that sounds a bit silly, but actually, if you think about it, our body does a lot of things in a kind of pre-programmed way. Like many of the bodily functions that we carry out every day to survive are done in a completely automatic manner. It's not like we decide uh, when our heart has to beat, or even if we don't have even control on many of our body parts. So but then who has programmed this machine is been programmed by biological evolution, right? But from this point of view, it's also debatable on what is intelligence, what is a machine, and so on. And some people goes as far to say that we humans, our goal in the universe is just to create AI so that then AI can survive and live for many thousands or millions of years after we'll be gone. Um, and this makes sense in a way, because unless we find a way to colonize other planets at some point, planet Earth, if not because of climate change, when the sun will expand, then humanity will be gone, and supposedly only AI will be left. And AI, in fact, has the potential to even colonize other planets, because it doesn't have our biological limits. So I wouldn't go as far as that into thinking of what is the role of AI and humanity, but nonetheless, maybe this is a good time to be asking some questions, like, for example, if we are building an AI after us, is it even correct for us to build an AI and use ourselves as a model? Are we a good model for an artificial intelligence? And this seems like a stupid question, but actually it's not, because many of the things that we invented are sometimes, yes, inspired by nature, but not everything. For example, planes do not flap their wings and still they work. Other things come from the replication of a natural phenomenon, but not all of them. So it's an interesting question um, to think of whether AI needs to be something that reasons like us and has our same beliefs and behaves like us, or it can or must be something completely different. And then for those, especially for those working on affective computing like us, a very important question is, do I want to give an AI the full spectrum of human emotions, or do we want to leave some out? Do we want to have only positive emotions for example, um, in a robot, or only or the full spectrum? Or do we actually even want to leave emotions out completely? So these are questions that people are asking now, but even Marvin Minsky back in the days asked this kind of question in his book, Emotional Intelligence, where one famous quote from him was, the question is not whether an intelligent machine can have emotions, but whether there could be an intelligent machine could really be intelligence without emotion. So this is just to state that IQ and EQ sometimes are very much intertwined, and many of the reasoning and things that we humans do in our daily life, no matter if it's short-term or long-term planning, are actually very much tied to emotions. Even the way our memory works is tied to emotions. Another question when we talk about robotics is how should they look like? And this is also a question that dates back to the 70s, the famous uncanny valley problem, whereby robots that don't really look like humans at all don't cause any problem. But then when you start trying to emulate humans as close as possible, unless you have something very, very good, like, for example, the Sophia robot, you end up in this valley where people feel very uncomfortable with what they see because it resembles a bit like a zombie rather than something that you feel comfortable with. And then another important question that even at political level now has been discussed is whether we should have some AI guardrails to limit AI's intelligence to make sure that actually the AI singularity is never reached. But there are many other questions that some would say like they are a bit philosophical, like if we manage to really build something that is truly intelligent, then how fair would it be to keep it trapped in our server, computer, or phone? So it's an open debate that it's going on in both politics, business, and academia. There's this nice two-page article from IEEE Spectrum from 2 years ago that you can take a look at, and this charts, plots where every major AI scientist is in terms of what they think about AI and how is highly probable to have AGI, and at the same time that AGI will be dangerous for us. So you see some that they are a very high spectrum, and Geoffrey Hinton is here, and Gary Marcus is here. If you know, Gary Marcus is one who thinks that we still have a lot of things to do before we reach true intelligence. He's a promoter of common sense, knowledge, representation, and reasoning. So if you ask me, I would be more in line with what Gary Marcus says. But then it's also true that 1 year after this, Geoffrey Hinton got the Nobel Prize. So maybe we should listen to him. I don't know. Recently, I don't know if you saw the news. There was a debacle between Geoffrey Hinton and Elon Musk. So Geoffrey Hinton tweeted something saying that what Elon Musk is doing is wrong, and now Elon Musk is replying back, and you have kind of the academic community backing Geoffrey Hinton, and on the other side you have all the Elon Musk supporter going against the Nobel Prize. So it's a bit funny to see, and but this just happened. Let's see what will happen next. So, but this is also happening in the business world. Many people think different about what AI is going to do to us, whether it's something good or bad. The truth is that AI is neither good or bad. It's just a very powerful tool, and it all depends on who uses it and how it's used. And this happened many times in the history of humanity with the atom, with genetics, for example. These are very powerful tools that are not either good or evil per se. It only depends on how they are being used. But personally, I don't believe in those apocalyptic scenarios where AI is gonna enslave or kill us all. The real risk that could happen is that we build an AI to solve a real problem, and we give no guardrails, no limit to this AI, and then there could be some sort of unexpected consequences where maybe even we can be harmed by this AI in unexpected ways. And these are the so-called paperclip scenario that were brought up already some years ago, where, for example, you have an AI that is tasked to do as many paper clips as possible and given no limitations, and then it wipes out humanity with the goal of just blindly producing as many paper clips as possible. So you may think this is very stupid. Again, how can something like this happen? It's impossible, right? Actually, it has already happened in some ways with plastics. Plastics were an amazing invention about a century ago, which really helped us to evolve as a society and a civilization, but now it's actually threatening our own existence. And this is because we sometimes it's very hard for us to predict what's going to happen next. When there's something that is looks like only have positive aspects, then maybe down the road, 100 years down the road, can have also unexpected consequences. So that's with all this in mind, we came up with these 7 pillars for the future of AI, which again is not a futuristic vision of what's going to happen next, but more like a research manifesto and call for participation for any of you who wants to work on this. So in the next few slides, I'm just going to briefly describe each of these pillars, and then if you want to discuss more about this, we can discuss it later. If you want to know more details about this, you can also see chapter 1 of the textbook. So the first one is multidisciplinarity. I want to stress this again. After yesterday, we made the example of linguistics. Unfortunately, now with large language models, many computer scientists are becoming a bit obsessed with just having these mathematical models, which are great, achieve high accuracy on many tasks, but still we cannot forget the decades of literature on linguistics. We have to look at other things that go beyond word embeddings and mathematical models to represent language, because once again, statistics are good for numerical data, but for language, we also need something else. So I'm not just talking about linguistics, I'm also talking about semiotics. We'll talk about semiotics later when we talk about symbol grounding, but also psychology. So if you're working like we do in affective computing, instead of just blindly choosing some classes to do emotion categorization, why not reading up some psychological studies on emotions and use or come up with an emotion categorization model that is psychologically inspired? And same with other things that we discussed yesterday in terms of sociology, ethics, and many more. Even now, in education, we are looking at expanding the standard STEM disciplines to also include arts, the arts, and how AI, for example, can be useful for arts, but also arts can be useful for AI. I'm going to talk about this at the very end of this course when I give you some examples of our applications, and one are also in the domain of the arts. The second pillars is actually something that we are going to talk about in details later in the next lecture. Lecture 4 is about the suitcase model. And what is the suitcase model? It's just a framework that contains a lot of NLP tasks. So what's the meaning of this? We'll talk later about some of the benefits of using this framework rather than just focusing on training a neural network with a specific downstream task in mind. But the idea here is that in our mind, there's a lot of tasks that we do almost unconsciously when we try to understand, when we read text, when we hear someone speaking. And it's a mistake to just train a neural network for a specific downstream task, like, for example, polarity detection, and expect this model to automatically be able to handle all the other tasks that we normally can handle. Because if I don't train the model for it, it's a bit risky to assume that it will automatically take care of it. So I'm talking about some of these tasks, like the ones that we can see here in this image and that we'll talk about later in next lecture, like word sense disambiguation, for example, or metaphor understanding. Many of the things, like also anaphora resolution, it's something that we do almost automatically. We don't have to think twice. Every time we see a pronoun in a sentence, we can immediately tell what this pronoun stands for. But it's a mistake to assume that a model can just learn all these in an automatic manner. Then, as we will discuss also in the next lecture, having a framework like this not only can increase accuracy but also interpretability, because then if you have different tasks, then you can see which task is doing what, and it becomes so much easier to see where your system is at fault, to do, for example, an ablation study or error analysis on each of these modules. And here, once again, I'm not saying that we have to use all these modules all of the times. It depends on your application and your data. So, for example, if your data doesn't have any sarcastic content, you don't need to do any sarcasm detection. If you're working with formal data, then you don't need a microtext normalization task. I see a question by Vivek. Please ask your question.
Hello, Eric.
Hi.
I just wanted to know, for the point you have written subjectivity detection, do you mean subject detection in the sentence?
Again, this is the next lecture is all about these 15 tasks. And by subjectivity detection, I mean the task of polarity detection to distinguish between subjective versus objective content, where subjective content is all those is opinions, basically. It's content that is either positive or negative, while objective content is neutral content. And this is, we'll discuss this later. For polarity detection accuracy, is so much better to apply subjectivity detection first and then do polarity detection. Why? Because many classifiers, like for example SVM that we talk about in the first lecture, are binary classifiers that are optimized to classify something as either positive or negative. So if you just use that, and maybe the classifier will be forced to classify something as positive or negative when in fact something is neutral. So yeah, subjectivity detection module is basically just filters out neutral content so that you can focus just on either positive or negative opinions.
Okay. And for the last row, I have one question about that. So,
Which one?
in the last row, pragmatic
Yes.
layer, you
Mm-hmm.
have written aspect extraction.
Mm.
So, from the linguistic perspective, I believe that aspect is like extraction is more like a syntactic task where you have aspect markers and you try to understand what is the nature of the sentence itself. So, how can it be pragmatic?
So thanks for asking this, because then this is also called different ways in different disciplines, because we focus on affective computing. Aspect extraction is more like in a sense of aspect based sentiment analysis, and in some cases it also goes under the name of topic modeling. Here the idea is to do a finer grained analysis that doesn't just look at the sentence as a whole, but tries to break it down into some subparts. So these subparts in sentiment analysis are called aspects, but you can also call them features. So you can also call them opinion targets. And you can only do this properly after you've done a lot of other tasks. That's why it's there in the last layer. But this structure is not very strict, in a sense that even the sequence of these tasks is not fixed. It really much depends on the kind of data that you're handling. So this is just a proposed way to do mostly polarity detection, but many other downstream tasks. We also built our chatbot using this kind of framework, and we also then go beyond that by using polarity detection for many other things like depression detection, suicidal ideation detection. But then, yeah, for us, what I mean by aspect extraction is to extract the structure of the sentence in terms of what are the opinion targets, what are the focal points, what are the key words that you need to then do a more finer grained analysis. But we'll talk about this in the next lecture with some examples that also show how aspect extraction is very useful for comparative analysis.
Okay, okay, that will actually help with understanding this thing through example.
Thanks again for your question. Any other question?
Not yet, but I have one question which I will ask after the end of this session.
Okay. Okay, so again, we'll talk about this suitcase model later, and we are here talking about the seven pillars, and this was just the second one. So first is multidisciplinarity. Again, very important for us AI enthusiasts not to forget that we also have to take into account other disciplines. Task decomposition, again, don't, it's good to use neural networks and just throw as much data as possible to learn a specific downstream task, but sometimes it's better to do task decomposition to look at each of these tasks separately. Parallel analogy is also a very interesting topic that was once again proposed by the late Marvin Minsky. And it's very interesting in a sense that I think today it's really something that we need. So once again, as AI experts, we or as engineers in general, we tend to be a bit too obsessed with optimization. So when we are building an AI model, we want to pick the best representation, the best set of parameters, the best model, and so on. But sometimes maybe it's better to have even the same data represented in different formats instead of just picking the best. Why? Because then if you have a dynamic system that can shift from a representation to another, then you have a much more robust and flexible model that can maybe switch representation when problem solving starts to fail, a bit like we humans do when we want to like look at the problem from a different point of view. So this is something that we are also doing for affective computing tasks, and I think it's something to be taken into account. Symbol grounding is something that I mentioned many times during the previous lectures, and it's the central pillar, not by chance, and that's because it's something that we really believed on in terms of uh, like what is one of the biggest limitations of current AI that needs to be fixed or at least mitigated. So this comes from the field of semiotics, and this is also something that we're going to talk about a bit more in detail in lecture 5 when we talk about neurosymbolic AI and common sense knowledge representation and reasoning. But here is a preview of that. This means grounding words and meanings somewhere. So this is something that we just discussed before the break. So if I take a verb like generate in a large language model is just associated to an embedding. I don't have a meaningful representation that tells me what generate actually is. Yes, I can ask ChatGPT to give me an explanation. Yes, I can get hundreds different synonyms of generate, but what really generate is a different question, because then once again, a large language model given a question is just going to generate an answer for you, but that's not how we reason. We try to really visualize what's happening. So having a sort of grounding that tells me that, for example, generating X means that I go from the current state of affair of the operating environment where X doesn't exist to a new state where X now exists, can be very useful for doing, for example, spatial reasoning. And then on top of this, I can build a lot of other um, types of meanings and concepts. But here, the most important concept is that in order for me to have something, a model that is, I wouldn't say truly intelligent, but at least cognitive inspired. Words, it's good that words are associated to embeddings, but they should also be linked to some sort of explanation or meaning encoding and decoding, so that the meaning of having these specific set of letters coming one after another is actually grounded somewhere. And the power of this is that once you have a representation like this, that is language agnostic, actually supposedly it's valid for all existing languages, because languages, once again, are just a standard. So why not try to build some sort of universal symbolism that can, on top of which then we can use all languages. Similarity measure is also very important. We discussed this when we were talking about Euclidean distance and cosine similarity in lecture one, if you remember. And today, even people that are building better and better AI models, when it comes to doing classification or calculating similarity between the data points, they actually still using either Euclidean distance or cosine similarity, mostly cosine similarity for the reasons that we explained in lecture one. But then recently, some people are correctly pointing out that cosine similarity may not be as good as we thought. And there's this famous paper published in WWW conference by Netflix that basically shows that cosine similarity, at least for their data, doesn't really work. So it works for very simple problems. In general, cosine similarity, don't get me wrong, it's a very good way to calculate the similarity between any kind of data, but it's not always working perfectly. So for Netflix, which is maybe slightly different, it's not exactly a classification problem. The one that they have is more about a recommender system, so maybe closer to clustering. But for them, as shown in this paper that you can read, is not very good. And actually, that's also our claim in CenticNet 7, for example. 2 years ago, we came up with a different way of calculating similarity in a vector space. Why? Because when you talk about similarity, cosine similarity, you're actually trying to look at the angle between two vectors, like we discussed. But sometimes these two data points could be in two completely different manifolds of the space. So the space is not just a set of points. The points tend to organize themselves into manifolds. And sometimes you could have 2 points that, from a Euclidean point of view, are very near to each other, but they belong to two different manifolds. And so looking at the pure similarity without taking into account the topology of the space could actually be a mistake. So we are working on different ways of calculating this topology aware similarity. If you are interested, we can discuss more later, or you can take a look at our paper CenticNet 7 from 2 years ago, actually 2022. Another thing to mention here is that once again, when we talk about cosine similarity, we tend to think that that's the only similarity, like a semantic similarity. But then there could be also other different similarities at play. So one example in our field, affective computing, is that if you have two data points, two concepts like happiness and sadness, from a semantic point of view, maybe they are actually very similar because they are both emotions. But then from an affective point of view, they are completely different. So um, they should be in completely different areas of the vector space. So that's exactly why we came up with an affective version of a vector space model, affective space, which focuses more on these nuances rather than looking at the more general semantic similarity. Another important pillar is intention awareness, which in general means creating a model of the user, like doing a bit of user profiling so that um, you don't just give general answers in the case of question answering, but you can actually cater to the specific preferences of the user. So I'm going to talk about this a bit later when I give you some examples of how we do this in our group. But here is another short paper published last year in which we talk about all the some of the possible different degrees of personalization that you can apply to basically have a better human-computer interaction. So even when you talk about sentiment analysis, if you just have some personality detection there, then you can better understand whether a piece of text is positive or negative depending on the personality of the user. And here you also have subjectivity, which is different from subjectivity detection that we mentioned before. Here, subjectivity means knowing basically the personal preferences of the user. So if you get to know from some user data or metadata, for example, that they love pizza and they are allergic to shrimp, the next time when even just you write, you see a sentence like my dad brought me to eat shrimp. It's neutral actually because it doesn't contain any positive or negative information, but knowing the personal preference of the user, you know that that's actually negative. And finally, trust. How to define trust between even two humans. It can be tricky. That's why we also have to look at other social sciences to define and to have a good definition of trust, because trust actually is very similar to those other words like intelligence that we understand more or less what it means. But when you have to define it in a way that you can build it from scratch, then it's a bit tricky. But here in this pillar and in this short paper or in this also short video that you can watch later, we discuss about trust specifically in the context of recommender system. And here, actually, the question is really important. Like we use recommender systems much more than we realize. Like so many of the products that we use, like Netflix, but even things like, I don't know, dating apps, they are all recommender systems. And here the question is, who tells me that the next item, person, book, video, restaurant that is being recommended to me is really for my own best benefit? Maybe it's actually following the business model of the company. So how do we know? How do we know about that? We need more transparency. We need to be able to trust our recommender systems by, for example, being able to see or ask how they came up with this the next recommended item. And once again, this seems like a trivial question, but it's not so trivial because in some cases, like for example, dating apps, the business model and your goals are exactly the opposite. Maybe you go on a dating app to find your life partner, but and so to get off the dating app as soon as possible, but then that's not the business model of the dating app who wants to keep you there for as long as possible. So these are important questions to ask. And in this paper, we also talk about many other interesting things, like the fact that this over reliance on recommender system and AI may actually cause humanity to have a simpler and more rare interaction among each other. Because then here the question is, if I have I don't know if you watched the movie Her, but if you have some sort of recommender system that you can really talk to and it replies back in a very natural manner, and it knows you so well that can give you the best possible recommendations, then what's the point of even having any interaction with other human beings? So that's another kind of philosophical questions that we can also discuss later if you are interested in this kind of topics. So this concludes actually this lecture, and I'm happy to take any questions. So I don't, it's a bit difficult to do a course like this online. Like last time I was at IIT Patna, I can see the faces of you guys and I know whether you're getting excited, bored, or whatnot. So this course, maybe last time the course was a bit more technical, so there were more um it was a bit more hands-on. This time I thought it's better to do something a bit more high level, and then you have the tutorials to do something a bit more hands-on. And for those of you who are more interested in the details, you can go and read the textbook or look at some other of more technical short videos that we have on our channel. But then I'm also happy to hear any sort of feedback in terms of like if this is what you expected, if this is useful for you, and if you would like to be more technical next time. I don't have time now to change the slides. We only have two lectures left, but I'm always happy to get this kind of feedback. I'm doing this a bit high level because I think that's what you need. And now in the business world and also in academia, it's relatively easy to find like code on Hugging Face or Spacey, but then it's more important, I think, to have a bigger vision and understanding of what are the limitations and strengths of AI so that you know what to do next in your specific field. So that's why I'm teaching this course this way, and that's also how recently I've been teaching to my students in the university. Of course, at the university we have more time, and we are also doing more practical things, more tutorials, more assignments, and more hands-on experiences. But it's actually very similar to what I'm doing here in this course, maybe in a bit more condensed manner.
Eric, I have a question for pillar number 4, if you can move to that slide.
Sure.
I'm going to ask you some basic questions related to that. And
Please.
because this kind of intrigued me in a very different way. Uh, so if I see logic definitions, first my question is, Is it really possible to logically define each and every entity of a language?
No, uh, it's this is something that people have tried in many ways. The very first attempt to do this was Psych by Doug Leonard. And then recently, you also have also efforts by linguists like Bliss Symbolics was an interesting project as well. And Shang also came up with the concept of semantic primitives. I'm not saying that we have to do this for every word in every language. Probably it's not possible to do that, especially for abstract concepts. But starting to build something like this for a specific application or a specific domain, like we are doing for affective computing, can be useful later on to build something on top of this. So this here I do it with logic, but I'm not saying that it must be done with logic. What I would like to have in the future maybe is some sort of visualization tool that makes, for example, an LLM imagine things as it's reasoning, like visualize a certain scenario, a certain situation. This once again would only work for very tangible objects and not for abstract concepts. But then, yes, to answer your question, it's not feasible and possibly impossible to create this kind of logic definition for every word. In fact, what we did here in CentiNet 7 and CentiNet 8 was to mostly focus on just verb concepts and only those that are polar, so either a positive or negative concepts, because then for other concepts that are more neutral or more abstract, sometimes it's very difficult to come up with a logic definition for them.
But I see defining through a very explicit boundary of positive and negative, then there is a problem. Let's say I want to logically define a predicate or a word. Let's say ungenerate. How do you define that?
Ungenerate,
Yeah,
you mean the opposite of generate,
yeah. So how would you treat that?
as this as the opposite state that goes from X existing to not existing.
But it don't you think it is more like a case of saying that. Um, so suppose if I take an example of boy and girl, okay, and somehow I believe that girl is an opposite property than the boy. But then if someone comes up and he defines unboy, means unmaking of a boy, it's not a girl, but it's not a boy either. So
Yeah,
I think if I treat ungenerate as an equivalent of that, so I'm
it's
not
true. Yeah.
considering it as an terminate thing.
It's a very good point that you're making. I can't think of a specific example, but there is actually a way to define this in logic. So there is the opposite or the negation is one thing, and then the complement is another. So, for example, I get your point. Like generating something, the opposite of generating, the question is the opposite of generating something is doing nothing or terminating something. So this is something that you can still define in logic, and but then yeah, we have to be able to make this kind of differences. And in many cases, like you said, it's not true that everything is black and white. For those, maybe you want to be using fuzzy logic instead of a more binary classification. So I hear you. There are many things that require that for which like standard first order logic is not enough or is not good. But again, this is more about an attempt, an example of how we can and should try to mitigate, if not solve, the symbol grounding problem.
Okay, okay. So in case if I for my hypothesis, I take okay, it's possible to define things on a black and white term. Forcefully, I think of that. Okay. So in that case, suppose I wish to define a predicate, which may be like um, self-containment, and it's a mix of generation and termination. And I wish to use these tools which you have written over here, that there is not x implies some x, and if there is an x implies not x. So how would you join them, or how would you add them, sum them, in order to define the predicate like self-containment?
I don't know. We have to come up with some ways to define things that are more complex. What we do in sentiment analysis context is also to define a time dimension. So, for example, um, when you have like the primitive barter, exchanging like a double transfer of ownership, but then depending on what you're exchanging and for how long, the meaning change. So you have to combine different primitives and think of way to also include the time dimension, because the same primitive like barter, exchanging of A for B, takes different names in English. If one of the items that you're exchanging is money, then you can have buy or sell. If you keep it for a limited period of time, then it becomes lending or borrowing something. Or if you take it against someone will, then you're stealing from someone. That the exchange, like the primitive is the same. It's an exchange of objects, or getting an object from someone or something, but then you have to add on some other representation that can specify maybe with the time dimension, or some sort of like willingness of the other party to give you or not this object, to then specify what it means. Here, what we're trying to do definitely, ultimately, is to take this top-down approach where we find a way to represent a specific meaning, and then from there we go on and see how many um, how many words in English or in any other language correspond to this kind of transfer in different contexts. So again, I'm not saying that we can do this for all words. For some will be impossible, for some will be more complex. We'll have to come up with different techniques to do this, but I think we should try at least. Given a simple set of primitives and a specific domain, I think this is doable and can result in maybe a new learning or reasoning paradigm that can then later on be adapted to bigger problems.
Okay, and one last question related to this. I'm sorry, I'm taking much of your time.
Oh no, we are here. We still have another 10 minutes, so no problem.
Okay, so suppose again I further make a subset. Okay, these are some properties, and these are the things I can define in a black and white thing. So where do you sit this small set of work uh, to be working or to be producing good result in a scenario of LLM? Where do you think this is fitting actually?
Yeah, that's also a very good question, and I'm gonna talk about it in lecture 5. So, but we also mentioned that yesterday. You can have a hybrid model where you still use an LLM, like we use our intuition for a fast reply, and then you can have another system. So this is also called in cognitive psychology system 1 and system 2, where you have a framework like this one that can verify facts, that can do different kinds of reasoning, like common sense reasoning, because then you don't really need to have this representation maybe some basic question answering task. But if I start telling you a story, or you have to understand a scene where a specific object is moving between different hands and people are moving around, and then you have to understand where this object is, and then maybe you need a kind of reasoning like this. So I'm not saying that we have to come up with this representation and use it for everything. I'm saying together with LLM, you should also have another, maybe more than one ways of reasoning, and we should have a system that is able to switch not just among different representations like we saw here, but also switch among different ways of thinking.
Okay, thanks a lot. That was really insightful.
No problem, my pleasure. I see there's another question by Palash.
Yeah, hi Eric.
Hi.
So I don't have a question per se, but I need your insightful comments on something
Mhm.
that we are doing right now.
Sure.
So I don't know whether you are aware of the Bhashini initiative of Government of India or not. So under that initiative, the government is planning to build MT systems or MT technology for Indian languages, uh, covering all the 22 scheduled Indian languages and apart from that, other regional languages as well. So what approach we are following right now is developing the parallel corpora from Hindi to Indian languages and then training the MT systems based upon that. So, I mean, what is your take on this approach and what is your feedback and what more you would like to add in this?
Yeah, thanks for telling me about this project. I didn't know about it and I want to know more because actually here in Singapore, we are doing something very similar for Southeast Asian languages. So I'm collaborating with this institute called AI Singapore, and we are building large language models for Southeast Asian languages. The models are actually open source. It's called Sea Lion. Sea Lion stands for Southeast Asian Languages in One Network. So Sea Lion, you can Google that or you can ask me for the link, and you can take inspiration from that for your work. In general, I think it's very good to have that because then our experience in other Southeast Asian countries is that every country has different problems, and you really need a model for each of those. But I think one thing that it's also missing from there is the thing that we just discussed here. We should also have, on top of these large language models, also other sorts of symbolic AI or knowledge representation that, for example, can understand the different cultural nuances between different Asian countries or different regions of India, so that, for example, you have one large language model that is more nuanced towards the specific beliefs or foods or ways of thinking of people from that specific region, because that's the only way you can really do personalization. So this is also related to the thing that I was mentioning in terms of intention awareness. And unless you build a large language model for each of these facets, you also need, in any case, you also need some other model or framework that can help you understand all these nuances. So once again, I would have, if possible, I would have some sort of system one, system two framework that, yes, uses a large language model trained on location specific data, but also a knowledge representation or a knowledge base, even something as simple as an ontology that tells you what are the specific cultural or even religion or other kinds of differences between these different user groups, basically. But yeah, tell me, So tell me more later. Maybe you can have discussion separately or send me an email. I want to know more
Yep.
about this project, and I can
Yep.
also tell you more about Sea Lion.
Sure, definitely. Yeah, we'll connect.
Okay, I think it's time to stop here. You guys probably have the tutorial next. If there's no more questions, then I would say
Pro-
yes.
Prof- Professor, are you
Yes.
going to talk about ethics in AI anywhere in your lecture?
Ethics, no, not really.
So maybe in the future lecture, if you can talk about the research scenarios, I mean, just small discussion about what is the idea of ethics when we talk
Mm.
about AI ethics.
Yeah, thanks. I will. That's a good suggestion. I can add more material on that next time. The only thing that is near to ethics is this concept of the responsible recommender systems, but definitely there could be more that can be discussed in terms of ethics, because again, it's one of the disciplines that I also added here in the first pillar. But then you're right, I don't talk much about ethics in this workshop. So yeah, thanks for the advice. Okay, I guess I'll say goodbye now and enjoy the tutorials. And if you have more questions, you can ask me tomorrow. So see you guys tomorrow at the same time for lecture 4.
Thank you.
Bye bye.
Bye. Thank you.